All right, CNT120, Chapter 1, we're looking at OSI model. We're going to pick up at layer 4 now and work our way down. We just got done with layer 5, session layer, so we're now on transport layer. Transport layer is actually pretty important now. There's some pretty important stuff going on here. We're going to interact with the TCP or UDP protocol as an example. The transport layer is responsible for transporting the application layer payload, like our HTTP data, from one application to another. So in other words, from my computer, my request from my computer to the server, and then the server has to send the data back to my browser, if you will. So the transport layer is responsible for doing that, and doing it reliably, so to speak, in many cases. The two main transport layer protocols are TCP and UDP. TCP, Transport Transmission Control Protocol. This makes a connection with the end host, checks whether the data is received, and makes sure it all gets there. If a piece goes missing, it tries to have that resent and get all of the stuff to my computer. This is called a connection-oriented protocol. It checks to make sure, are you ready, server? Yes, I'm ready. Okay, let's send. All right, here it comes. Did you get it? Here it comes. Did you get it? Here it comes. Did you get it? It's constantly communicating to make sure everything gets there. Very reliable. Meanwhile, the other protocol at layer 4, I like to call it the evil twin, if you will, UDP, User Datagram Protocol, does not guarantee delivery by first connecting and checking whether that is received. This is connectionless. So this is not going to do any of that checking to make sure it got there and are you ready? Here it comes. Did you get it? Did you get it? Okay, it's not going to do any of that. Well, what we're going to see is, as I take a look here, I think I have this on the next slide, there are some protocols at the upper layer application that need the reliability of TCP. Meanwhile, there's some protocols up here in the upper layer that do not need the reliability of TCP, so they use UDP. So what happens is the upper layer applications that need the reliability to make sure everything gets there are going to use TCP at layer 4. The ones that don't are going to use UDP. Now, the question often pops in your head is, do you have a choice? No, you don't. The way FTP works is it uses TCP. The way HTTP works, it uses TCP. That's been long figured out and coded long before probably some of you were even born. Meanwhile, some things do not need that reliability and are going to use UDP. And because of that, they're going to be quicker. They're not going to be reliable, but they're going to be quicker. They don't have all that overhead. So just kind of sort those two out in your brain right away. Now let me back up here real quick. TCP now. Transmission Control Protocol makes a connection with the other end, checks to make sure it's there. Some of these upper layers need that reliability. There is that added overhead of checking, but it's going to make sure my entire web page gets to me, my entire email gets to me, my entire file gets to me. Because if I don't have all the email, if I don't have all the web page, it's not very useful. So adding that overhead to slow down the transmission a little bit to make sure everything gets there is necessary. Again, a half a web page is not very useful. Half an email is not very useful. So TCP adding that overhead of making sure, are you there? Okay, here it comes. Did you get it? Here it comes. Did you get it? Here it comes. Did you get it? That added overhead is necessary to make sure I get all of this stuff. So that's why I put this on the next page to get you to realize some of these upper layers are going to use it. That's just how it is. Emails, web pages, file transfers are going to use TCP. Meanwhile, UDP does not guarantee, so upper layer applications need the efficiency. I need the data to get there quickly with no delay. So I'm not going to check. I just want to get it there. Some things like domain requests, IP address requests, voice and video need this speed, if you will, and will sacrifice the accuracy just to get it there quickly. So again, some of these upper layer things here, as you see, getting my IP address, DNS is not there, but getting my domain name quickly, those kind of things I need quickly. So I'm going to use, say UDP is going to get used, if you will. They also start mentioning here at layer 4 transport layer that protocols add their own control information. They add their own header. Well, this process is called encapsulation. Okay. Excuse me. Data encapsulation is the process of preparing data to be sent across the network. If you remember when I said in like last podcast, sending a letter, if I package my letter correctly, it will get through the postal system into my recipient halfway around the world, as long as I do it correctly. Well, if I package my data correctly using these headers, it will get through the network and to the computer I want it to get to. So let's start following this now. These are my little drawings. These aren't in the book. These are my little drawings. Here's my HTTP. Let's say I'm going to request a web page from a web server. So here's my little HTTP request. Application layer. Okay. Presentation layer. Again, it's making sure it's HTTP, formatted, not compressed or anything weird. Session layer is making sure, hey, this session is going. We're going to maintain it. We're going to watch it. As I get to layer 4, I'm going to add a TCP header. We're going to talk port numbers in, I believe it's chapter 2. So we'll come back to TCP port numbers later, but layer 4 is going to start adding its own little header here of control information that the server is going to be able to read to know what the heck is going on. Kind of like adding addresses to my letter. Before I send it, I need to put a person's name on. I need to put their street. I need to put their city. I need to put their zip code. Then I need to pair my address and my name and my address and my street and my town and my zip code. I have to put all that stuff on. So here we're starting to add a port number. So in other words, the server would then know to listen, oh, this is a web request. Okay, I know what to do with this. All right. And it's now called a segment. When I do this, when I add this little TCP header, it's called a segment. Stick that in the back of your brain. We'll put all these together in a few minutes. As I move on to layer 3 now, that was layer 4, TCP, UDP, reliability, TCP overhead, UDP speed, okay? Now as we move to layer 3, network layer, this is responsible for moving the messages from one node to another. And I'd like to say by reading the IP address. Okay, so by reading the IP address, the network layer is really there to try to get it to the correct network. The routers are reading the IP addresses and trying to get your chunks of data to the correct network. Think of the giant hack network. A chunk of data comes in from outside the world. When it starts hitting the hack routers, if you will, the hack routers are going to decide whether it goes to Lancaster as opposed to Harrisburg. It's getting it to the right network. Once it gets in that network, something else is going to make sure it gets to the correct device. That's your switch, if you really want to know. The switch is going to make sure it gets to my computer as opposed to your computer, if we're sitting next to each other in the computer lab. So the layer 3 is all about IP addresses, and typically routers are reading the IP addresses trying to get things to the correct network. We'll talk about IP addresses more in chapter 2. Excuse me. Layer 3 is responsible for sending data packets to the correct network. Like I said, this is the job of the post office. The post office is trying to get it to the right house. Once it gets in the house, hey, they're like, you guys inside the house, you sort it out and figure out whose letter is who. I'm just getting it to the right house. That's the job of the network layer. It's just trying to get it to the right network, Lancaster as opposed to Harrisburg. Routers are the main thing that are operating at this layer. Routers are the main things. And here I give you some examples, some different routers, also reminding IP addressing scheme. We'll talk about that in next chapter. So now as I move my data down through HTTP request, there's my TCP header layer 4. That's just my segment. As I now get to layer 3, I add the IP header. You notice the TCP header does not go away. I'm adding it in front, almost like a little Lego block sticking on top of the other Lego block. And in here is the IP header of what IP address this thing's going to. This is now called a packet. Layer 2 now, we're now down where the NIC is. We're now down where the network card is. So layer 2 is really responsible for getting my data from my computer onto the network. So now I'm looking at the network card and taking my chunk of data and framing it in such a way that it gets onto my Ethernet network, onto my wired Ethernet network or my wireless Ethernet network, depending on what I'm trying to connect to. So this is really there to get it onto the network. That's why we're mentioning CSMACD, CSMACA. I have to get the data framed and onto my network. That's the job. And the protocols are just that. IEEE 802.3, IEEE 802.11, depending on the type of network we're connecting to. Wired Ethernet, wireless Ethernet, token passing. That's really old. You're not going to find that anymore, but just giving you an example. So this is all about the media access, trying to get my chunk of data onto this physical network. And I'm going to add on to that my Ethernet header, if you will, or my MAC address header. I'm going to add the MAC address and the Ethernet header to go out on the network. So now, if you think layer 3 added the IP address is trying to get it to the correct network, Harrisburg network as opposed to Lancaster network. And then now we're adding on the MAC address. This will be the MAC address of my computer as opposed to your computer, if you will. So now we also have in there the address to get it to the right computer, if you will. And that's information. My MAC address is burnt into my NIC. We'll talk about that in Chapter 2 as well. My MAC address is burnt into my NIC, so I now have the layer 2 address in my chunk of data that I'm trying to send through the network. Here's some examples of NICs like we looked at earlier in switches. This is the main stuff that's operating on layer 2. So if I look at my data encapsulation process, HTTP, layer 4, we added the TCP header. It's a segment now. As it moves down to layer 3, we're adding the IP header on. Again, think of it like a Lego block. I'm stacking it on top of the other Lego block. I now have the IP header. That's the IP address of the node or the network we're trying to get to, if you will. Now we add the data link header, Ethernet header. This now thing, again, it's almost like another Lego block stacking on the front here. This is now called a frame. This whole thing, this whole chunk of data now is called a frame because it has in the Ethernet header, or it has the Ethernet header on it and the MAC address inside. So we call this whole thing a frame, an Ethernet frame, if you will. Now with the physical layer is really about the cable or the wire, so to speak. So the physical layer is the simplest layer and is responsible for sending the bits. Ultimately, we're going to take all this data and convert it down into bits, and the bits are going to get sent across the wire or wireless network. So we're now going to stream a series of bits across the network, and that's the job of the physical layer. Physical layer is there to act as the pipe. I kind of think of it a pipe where the bits are going through. So it's either going to be a copper wire that the bits are moving through as a little electrical pulses, or a glass fiber that we're going to send light pulses through, or a specific frequency in the area that we're sending radio transmission through. We're sending our bits through in radio transmission. So layer 1 we're looking at, there is no addressing now. We have devices like hubs, repeaters, media converters. That's the only devices I really have here. Media converters are things that convert copper into fiber or fiber into copper. So converting electrical pulses into light or light pulses into electrical. So we're dealing with all physical entities. We're dealing with cables, connectors, ports, those sorts of things. And we're now dealing with bits. Okay, so my HTTP request, TCP header, it's a segment. I add the IP header, it's called a packet. I add the Ethernet header, it's called a frame. And now we're converting it to bits to move across the network. And now these bits will move through the network till it gets to its intended recipient. And this process will reverse. So on my computer, I'm sending my HTTP request, moving it down through, add the TCP header called a segment, add the IP header, it's called a packet, add the Ethernet header with a MAC address, it's called a frame. I convert it into bits. The bits move across the network to eventually, it's going to go through routers and all kinds of stuff and switches, and eventually it's going to get to your computer. Your computer now looks at the MAC address, yes, it's mine. Looks at the IP address, yes, it's mine. Looks at the TCP port number and goes, oh, that's 80, that's a web request. Passes it up to the web service, if you will, running on your server. And now it can respond to that. So that would be the de-encapsulation, receiving on the other end. So here it is. The book talks about all these names. If I put them all, in my own little chart here. Here's the 7-to-1, layer 7654321, data in the upper layers, segment, packet, frame, bit. And I have a little mnemonic over here of don't send fill for bill. That'll help you remember data, segment, packet, frame, bit. Don't send fill for bill. That'll get those data encapsulation units in the correct order for you. So the picture now shows you this idea of, in my browser going to the web server, I have to package it all up, move it across the network, and things like switches are going to read just up to layer 2 and back. Routers will read up to layer 3 and back. And these are all going to consistently make decisions and try to get it to eventually the web server, which will read the whole way up. It'll tear it all apart and read this web request and go, oh, you're looking for my web page. And it'll package it up and turn around and reverse the process back to me, the whole way back to me, so I can display it on my screen. So that's how all this is coming together. So make sure you know your layers, your OSI layers. Please do not throw sausage pizza away. And then don't forget your data encapsulation units. Don't send fill for build. Data segment packet frame bit.